Okay, we're going to solve quadratic equations again by factoring, and we're going to step it up just one more level that can be stepped up in factoring, and that is when we have our coefficient in front of x squared is not equal to 1. So we have some constant a that's not equal to 1, so like this kind of case right here where the coefficient on x squared is a 2 or something else. This is what we call standard form, when we can put it into the quadratic term, the linear term, and the constant term all equal to 0. So we want to organize it this way because we can use that pattern to help us factor things. And then since it's equal to 0, we can utilize that zero product property, ZPP. Okay, so the method of going through factoring is you take, instead of just the last term and you say what do you multiply, you take the first and last term and put it on the top. So I'm going to say this is going to be a times c x squared up here, and then it's going to be what new, and it might be a new factor, and it probably is going to be a new factor of this combined term. What do I multiply to get this number and add to get this number? And then, yeah, so then I'm going to get two factors of that. And those will go in the same spots that we're used to with our general rectangle. And this will be our quadratic equation, ax squared plus something or minus something. These two terms are going to combine to make my bx, right? And then this is going to be my constant term c. And then I will find my greatest common factor of these two terms and the greatest common factor of these two terms, which should be multiplying out to be ax squared. And then I say, well, what do I multiply this times to get that? Well, I'll just go through the whole process on this example in a second, but I just kind of wanted to get this picture going of the process that we do to factor these quadratic equations. So first off, this quadratic equation is not in standard form, right? It's not equal to 0, so I want to make it equal to 0. So I'm going to put that 3 over there by subtracting 3 from both sides to make it a 0. And now this new quadratic equation looks just like this. So now it's in this new form that I like, right? So I'm going to factor this. So I take my first and last term, and it's going to go on top. So negative 3 times 2 is negative 6. And then my middle term goes on the bottom, 5. So what do I multiply to get negative 6? But when I add, it's positive 5. So we could try, let's see, how about 1 times 6? If one of them was negative, this one could be negative, right? Yeah, so I get 1 and negative 6. So now I go over to my general rectangle, and I fill in, it was 2x squared and minus 3 here. So this is going to be negative x and positive 6. So negative 1x and positive 6x. So now to factor it, I take my greatest common factor of this row, which I could take out a 2 and an x, right? So 2 and an x. And then the greatest common factor of this column would just be x. So this would be 2x times what is 6x? That would be times 3, right? Positive 3. And then x times what would give me negative 1x? It'd be negative 1. And just to check to make sure I factored it correctly, I checked this last term. 3 times negative 1 is negative 3, so that is my check. Alright, so it factors into 2x minus 1 and x plus 3. You can multiply this out again just to make sure, and it should multiply out to be that, which combines to 5x, so that checks out, is equal to 0. So now I use my ZPP. So this is equal to 0 or this is equal to 0. And my shortcut is just to say the opposite of the back divided by the front. So this would be x equals positive 1/2, right? Opposite of the back divided by the front. Opposite of the back would be negative 3 divided by the front, which would be 1. So just negative 3 divided by 1, which is negative 3. So those are my two solutions to that equation. And I could check by plugging it back in. let's go ahead and just check the 1/2. How about 2 times 1/2 squared plus 5 times 1/2, is it equal to 3? So 1/2 squared is 1/4 times 2 would be 1/2 plus 5/2. So 1/2 plus 5/2 is 6/2, which is equal to 3. So that does check out. Okay, and I could check -3 as well, but I'll leave that up to you. All right, so the last, or this one here, will be, this is not in standard form again, so we need to rearrange it so it is in standard form. So I want to make this side equal to 0, and I could do that just by adding 15x to both sides, and then subtracting 6x from both sides, and I would end up with this, right? Because I'm taking away both of these things, so it's going to be 0 on that side. Okay, so I'm going to factor this. 15 and -6. You know what? I'm just going to leave it as the factored parts because I like to. I'm going to factor even that into its factors. So here's my prime factors, and it's negative. And I'm going to combine them in different ways to see what I can do to get this middle term. So this is a 1. All right, so it could be, 3 times all of those combined. That's not going to be a difference of 1. It could be, oh, look at this. I could do 10, right? 10 and 9 would be a difference of 1. So 10, 5 times 2, and 9. So 10 and 9 are my two factors, and one of them is negative. So this needs to be a positive 1, so this must be the negative. So I have 10x and -9x are my two factors. So I go to my general rectangle, and this would be 15x squared, 10x, and -9x. So the greatest common factor of this row looks like I could take a 5 out of both terms, 5x. And greatest common factor of this column looks like I could take a 3, right? Oh, 5x times 3x would be 15x squared. Alright, so 3 times what gives me -9? That would be -3. And 5 times what would give me 10? That would be +2. Alright, and then 2 times -3 would be -6, which checks out. Okay, so my factors are 3x plus 2 and 5x minus 3 is equal to 0. So opposite of the back divided by the front, so this would be -2/3. And this would be +3/5. Okay, so you can check that by plugging it in. I'm not going to though, it's going to be too long. Alright, last one. Let me just rearrange this into standard form. Add 3 to both sides. Okay, I'm going to multiply the first and last term. 30 times 3, so I'm going to rearrange these factors to get -23. So what is this, 3 times 10? Let's see, they're both going to be negative, right? So I need to get up, this is a positive on top, so but I need to get a negative number as a sum, so they're both going to be negative. Let's see, this is 3 times 5 times 2 times 3. Right? 10 times 3, yeah. Alright, so how would I arrange these? Let's see, 15 and 6. Is that up to 23? No. 9 and 10. No, that's 19. 15 and 6. I did that one. What else? What other way can I combine it? How about 6 and 15? No. What are my combinations here? So so I could do 3 times 3, which is 9, and 10. That didn't work. I could do, I already said 6 and 15 didn't work. I could do, well, just 3 and then 30, right? That didn't work. I could do 5 and, what is it, 9 and 2, that's 18. Right, so this is the one. So it looks like 5 times 18 would be a way to get 23, right? So 5 plus 18 is 23. So negative 5 and negative 18 add up to 23 x's. So I go to my general rectangle, and I say 30x squared, and then I split that into negative 18x and negative 5x. And so my greatest common factor of this row would be, can I take a 6? Yeah, 6x. And then the greatest common factor of this column, well, 6 times 5, right, would be 30x. Yeah, so 5 times what would give me negative 5, that'd be negative 1, and 6 times what would give me negative 16, that'd be negative 3. And negative 3 times 1 is positive 3. And that checks out. Okay, so my factor is 5x minus 3, 6x minus 1 equals 0. So x is equal to opposite of the back divided by the front, positive 3/5, or opposite of the back, which is positive 1, divided by the front, which is positive 6. So there are my two solutions to that quadratic equation. Okay.